Today's video is going to be a fun one and quite a journey actually. This is the second part in a two-part series on how to turn Ambisonics audio into Dolby Atmos. Now, before anybody disconnects too quickly, these two videos stand on their own feed, so you don't need to have seen the first one in order to be able to follow this second part. However, if you have seen the first part, you might remember that we used the Mach 1 transcoder in order to transcode Ambisonics audio into Dolby Atmos. And by doing that, or by using this software, we were able to do that in a completely no-cost way. So we didn't really have to purchase anything. Everything that we used was completely free. However, it came with a couple of disadvantages. One of them was that there was a lack of head information. The center channel was missing. Some of the surround channels were missing. So it was nice and it was very useful, but it was not perfect. So what we're going to do today is we're going to take it one step further, and we are going to use Cubase, and you could also use Nuendo. Both work in exactly the same way. But we are going to use Cubase or Nuendo in order to create a conversion that is of a much, much higher quality. And this is what we're going to do today. But first of all, hello everybody. In case you're new here, my name is Michael Wagner. I teach at the Antoinette Westphal College of Media Arts and Design at Drexel University in Philadelphia. And on this channel, I talk about digital media, game design, and spatial audio. And if any of those topics interest you, I invite you to subscribe or join my Discord community. And in that link is in the description below. And best of all, it's completely free. And with that being said, let's get right into transcoding some Ambisonics into Dolby Atmos using Cubase. The way I'm going to do this today is by starting with a completely empty Cubase project. You could also use Nuendo for that purpose. Works in exactly the same way. So either one is fine. I'm using Cubase because it's the one that's probably more accessible to a lot of people. And we are going to go through a lot of individual steps. So I need to warn you in case you lose track at some point, just rewind, watch again. And you might also find it useful to watch some of my other videos on how to set up a Dolby Atmos project in Cubase. But there are a lot of things that we are going to do. And we are also going to run into one rather nasty Cubase bug that we need to work around. So there's also a little bit of innovative workaround going on in this project. So the first thing that we are going to do is we're going to prepare some channels that we will need for the Dolby Atmos setup. And the first one, obviously, is we need to add a Dolby Atmos bus. And the Dolby Atmos bus needs to be a 7.1.4. It will later hold the Dolby Atmos renderer. And that will essentially be the one thing that holds and that will allow us to really convert everything into Dolby Atmos. So let's call that the Atmos bus. And I'm also already preparing a bed. So the Dolby Atmos bed is going to be a 7.1.2. Once again, that is the highest channel count that we can use for a Dolby Atmos bed. And we are going to route that into the Dolby Atmos bus. And let's call that Atmos bed. And let's rearrange them. And let's give them some colors. Orange is nice. The first thing I want to do is I want to see what happens if I just drop in my Ambisonics file and just use the standard Ambi decoder in order to convert that into a bed track, and then simply use that bed as an element in the Dolby Atmos project. You know, kind of in exactly the same way we did it last time with the Mach 1 transcoder. I can also do that in Cubase here, and in Cubase is actually very, very simple. But I would like to sort of see what type of information I'm getting, and I would also like to see what the quality loss will be if I'm using the Ambisonics and I'm turning that into a bed for a Dolby Atmos project. So the first thing that I'm going to do in order to find that out is simply adding the Ambisonics file. But the file that I'm going to use is exactly the same one that I used last time, and that is just a test file that has a series of beeps. And this series of beeps come from the 6 different directions, so front, back, left, right, bottom, top. And the idea is that this will essentially allow us, if the conversion or if the orientation or the three-dimensionality, let's call it like that, is preserved, and how much it is preserved in the conversion from Ambisonics into Dolby Atmos. So let's first do it like that. We're going to route that into the Dolby Atmos bed. So it's going to be routed into a 7.1.2 track. That means that the Ambi converter, the Ambi decoder in Cubase is going to take the Ambisonics, the third order Ambisonics, and turning that into a 7.1.4 format. Now, for reasons that will become a little bit clearer later, I'm going to give that the channel count, I'm going to name the channel count in the name of that track. So let's call that test audio. And let's add 7.1.2 into the name. And let's add that. Let's just move that up a little. And let's close that, I don't need that. And let's give that a color blue. And let's drop the audio into the track. And once again, the audio is something that I did last time with Reaper. Once again, a very simple Ambisonics file. If you want to know how I did that, just go watch the first part of the series. If not, doesn't make any difference. You can use any Ambisonics file, whatever you have, and whatever you can use. But we are going to use this particular test file. And this particular test file, once again, was just a series of beeps. And I'm going to import that. Let me close that again. And I should already hear something, but currently the test audio that's an Ambisonics file is going to be converted into 7.1.2, is then routed into the Atmos bus. Let me just double check if the rounding is correct, but I think it is. So yes, this is routed into the Dolby Atmos bus, and we should hear a series of 6 beeps. Now, obviously, we are not really hearing the front, back, bottom, top information, but we can already distinguish between left and right, because obviously we have left and right channels in a stereo signal. But in order to really find out how the energy of the audio is distributed, one way that we can do is by utilizing an energy visualizer. And most Ambisonics plugin suites come with such an energy visualizer, and that energy visualizer will allow us to really identify where exactly are those beeps. I also used this energy visualizer in the last video. Once again, go back and watch that. Here, what I'm going to do is I simply want to find out how much information is lost in this process when we take the Ambisonics, we turn it into 7.1.2 and then into 7.1.4. So the first thing in order to find that out is I'm going to drop an energy visualizer on the test audio. So that's going to visualize the original Ambisonics. And the one I'm going to use is I'm going to work with the IEM plugin suite here. I'm going to leave a link in the description below. The IEM plugins, in case you don't have them yet, they're completely free. They are very well done. They're very stable. They haven't been updated for a while, but they are really, really, really well developed. So you don't have to worry about those. And we are going to use this energy visualizer. And what this energy visualizer is doing is essentially showing us where exactly the energy of that particular audio is coming from. Is it coming from the bottom? Is it coming from the top? Is it coming from the front? Is it coming from the left, from the right, or from the back? So this is essentially a spherical projection, as a projection of a sphere. And that will essentially allow us to identify where exactly that energy is. So let's play the sound again, and let's maybe do a little loop here to make sure that we loop that and we don't have to restart everything all the time. So we essentially see where the energy is: front, back, left, right, bottom, top. I would now like to know how that energy is distributed once it went through the transcoding process. Once it went from Ambisonics into 7.1.2 and then into 7.1.4. Now, the one thing I'm going to expect is that I'm probably going to lose a lot from the bottom information, because in the 7.1.2 I only have overhead. I don't have anything underneath me. Dolby Atmos doesn't really have any channels that kind of play from bottom up. So I'm probably going to lose a lot of the bottom information, but I'm interested to see what's actually happening to the overhead information. And in order to find that out, one thing that I can do is I can convert the 7.1.2 that I've created in this process back into Ambisonics, and then use a second energy visualizer in order to see what the result is going to be. And that's what I'm going to do. So the first thing I'm going to do in order to make that happen is to add a helper track. That helper track will essentially just hold the energy visualizer of the output. And that needs to be a third order Ambisonics, because once again, the energy visualizer is an Ambisonics visualizer. So, and it's going to output to the stereo out, because we are going to run that through the actual output. And let's call that energy monitor. And let's add that track, and let's give it a color. Green. Not sure why green, a nice color. And then we're going to route the output of the Atmos bus into that Ambisonics track that will essentially once again convert it back into Ambisonics, and it will essentially show us what the resulting energy distribution really is. So let's just open that up and route that into the energy monitor. And let's see. So the last thing I need to do is I need to also put an energy visualizer on that energy monitor track. So let's do that. So we're going to insert an IEM energy visualizer here. And I now have two energy visualizers. One is the visualizing the energy as it comes from the original Ambisonics file. And this one is visualizing the energy once it ran through the conversion to 7.1.2 and then to 7.1.4. So let's see what the output will be. Now, not unsurprisingly, we have most of the information now on the horizontal plane. So it's sort of the mid-level really that we have. We have very little information in the bottom. We do have a little bit of information on top on the overhead. And in order to make that a little bit more visible, I need to increase the gain a bit. So let me just increase the gain on the Atmos bus. And I'm just going to use the gain slider here. Probably not the best way to do that, but for the purpose of this video, that's fine. And let's see how that essentially looks now. So as we can see, the last two. So once again, this is front, back, left, right, bottom, top. So bottom and top, essentially, they are, there's a little bit of information there, but not a whole lot. Now, if I'm working with Cubase, the highest channel count that I have available to me, and once again, I need to convert it into a channel-based audio because Dolby Atmos is channel-based audio. So I need to find a way to maximize the number of channels that I have available. And the maximum number that I can do in Cubase is a 7.1.4. So what I would like to do now is I would like to figure out how would the result be if I would not convert into 7.1.2 and then 7.1.4. But if I would convert directly into 7.1.4, would that sort of change anything? And the thinking is that 7.1.4 is really the first three-dimensional immersive audio format. 7.1.2 isn't really fully immersive. It's not really kind of a 3D format. So let's just see what happens if I turn that Ambisonics not into 7.1.2, but into 7.1.4. And the easiest way to do that is just for the purpose of demonstration here. So once again, this is not going to have any effect on what we're doing here, but the easiest way to do that is to simply route that audio not into the bed but into the bus. As soon as we route it into the bus, it's actually converted to 7.1.4. Once again, I'm not going to use that later on in this project. I'm just going to use that in order to demonstrate the result. So let's just route the audio into not into the bed, but into the bus. This will now convert the Ambisonics into 7.1.4. This is once again the highest channel count that we have available in Cubase. And let's see what the result will be. And this result was actually a little bit surprising. And that really threw me off. If you look at it closely, so once again, this is the input here, this is the output. You will actually see that the output is asymmetric. And the reason it is asymmetric is because of a bug in Cubase. And it took me actually a while to figure that out. But if you're taking an Ambisonics file and you're using the MB decoder that comes with Cubase, and you're changing the routing later on by changing the routing to a channel, to a track with a different channel count, it will actually not do that correctly. And what's happening here is it's actually losing one of the overhead channels, and that results in an asymmetric image. So we can't really do it like that, and that is very, very unfortunate, but also not that big of a deal because, as it turns out, if we start out correctly from the very beginning, it actually works. Now, what do I mean with that? Now, instead of kind of routing that audio into 7.1.2 and then rerouting it into 7.1.4, let me create a second Ambisonics track that is directly routed into 7.1.4 from the very beginning. So it's already set up that way. So what I'm going to do is I'm going to add a separate, and this, by the way, is the reason why I called it test audio 7.1.2, because that, once again, was originally routed into 7.1.2, and we rerouted it then into 7.1.4. But let's just route that directly into 7.1.4. So we're going to add another audio track, and in the other track, once again, is going to be a third order Ambisonics, and and the output is going to be the Atmos bus, and that will essentially make sure that the MB decoder is set up such that it is routing or it is decoding the Ambisonics, the third order Ambisonics, into 7.1.4. And let's call the test audio. I should type correctly and call the test 7.1.4. And let's just move that down here. Let's copy that down here, that track, and let's color that blue. And let's also kind of change that 7.1.2 routing back. So I had routed that into the bus. Let's route that back into the bed so that we sort of see the difference. And let's mute it because currently we don't really need it. So let's see what's happening with the 7.1.4 if we still have this asymmetry now that we've directly routed into 7.1.4. So for that purpose, let me just open up the two energy visualizers again. So we have the one, and the second one is here on the energy monitor. So once again, we have the input here, we have the output here, and let's play that. And as we can see, if I do it that way, it actually kind of works. So be aware that if you are using Ambisonics and you are using a track and routing and using the MB decoder to route to a 7.1.2, if you then later reroute that to a different channel count, the decoder will not decode correctly. And it's even worse. I now have that. Let me close that again. I now have that audio routed to the Dolby Atmos bus. So if I go in here, so this is the test audio. This is now routed to a 7.1.4 track. If I now change that, if I would change that to the bed track, guess what happens? Cubase, and by the way, Nuendo does the same thing, crashes completely. It sort of brings the entire system down. So I'm not going to do that here. So there is a severe bug in the MB decoder. But as we see, the result is not particularly useful anyway. So let me just open that up again. So we have once again, this is the input visualizer, and here we have here we have the output visualizer. So left, right, front, back are actually fine. So which is not surprising. And there are 8 channels essentially that kind of define the horizontal plane. But the bottom, we lost the bottom information. That is sort of expected once again, because we don't really have anything underneath us in Dolby Atmos. There's just no information coming from underneath us. But the top is not perfect. If you look once again, so that was front, back, left, right, bottom, top. So it is coming from the top, but not really kind of in the way I wanted it. In particular, I don't really have anything that's coming from the top back. That's sort of really a little bit annoying. Now we could go further with that, and everything that I'm going to do from now on, you can do with that particular decoder. That's perfectly fine. However, I'm not particularly happy with that decoder. So what I'm going to do is I'm going to replace the MB decoder that comes with Cubase with a different decoder, and the decoder that I'm going to use is obviously the one that comes with the IEM plugin suite, because everything that I'm going to use in this video is in connection with the IEM plugin suite. So I'm going to replace the MB decoder with the IEM decoder, the simple decoder, and that requires a couple of steps that we need to to do. The first thing is we need to put the IEM simple decoder as an insert onto the track that we want to decode. Unfortunately, it doesn't advertise itself as a decoder, as a panner. So normally when you have a panner, a plugin that works as a panner, you can actually go into the channel panner configuration and you can choose. Now, the IEM Ambisonics decoder does not really advertise itself that way, so we can't really do that. So what we need to do is we need to add it as an insert. So we're going to open up the channel inserts and let's just do the simple decoder. And this is the IEM simple decoder. And what we're going to do is we are going to set it into the 7.1.4 configuration that will essentially convert the Ambisonics into 7.1.4 using the IEM decoder. Now, if we leave it like that, I currently have the problem that I have two decoders in series, and that obviously is not working. So currently I have the IEM simple decoder, and then I have additionally the Ambi decoder that comes with Cubase. So I need to disable the Ambi decoder. Now, normally the way you would do that is you would simply bypass the panner here. Unfortunately, for the Ambi decoder, that doesn't work. So you need to, if I essentially bypass it here, it will just ignore the bypass. So what I need to do is I need to first change the panner to the standard panner, and I can then disable this or bypass the standard panner. So I'm going to go into the panner options, choose the standard panner here. I don't really need that window. Let's click that away, and I can then disable that. And now I have the panner completely bypassed. That essentially means the audio is now converted with the IEM simple decoder, and we are using that decoder instead of the Ambi decoder, and that actually will give us a much better result. So let's have a look on how this looks. So once again, the energy visualizer of the incoming audio, and here in the energy monitor, the outgoing audio. And let's play that file again. And I now have much better coverage of the overhead information. So I'm actually getting a pretty good information, but I can actually kind of even tweak it even a little bit more. And the way I will do that is by changing the weight of the simple decoder. And you don't really need to know what exactly that means, but that's just the way things are calculated, kind of in terms of how the individual components in the Ambisonics are weighted. To make sure that everything is sort of, the energy is kind of optimized, or that the decoding of the energy is optimized. So if I choose go from basic to max RE, that will actually, in this particular example, will give me the best results. But once again, your mileage might vary. If depending on the material that you have, you might want to choose different types of weights in the decoder. For me personally, this worked best. So let's see how that sounds if I do that. And that essentially brought a little bit of the bottom information back, and it also kind of reduced the top information slightly. So it leveled things out a little. And this is essentially what we're going to start working with. And I now need to convert that, or I need to kind of feed that into a Dolby Atmos file. And the way I'm going to do that is by feeding as many channels as possible into the bed, into the Dolby Atmos bed. And all the channels that I cannot route into the bed, I'm going to route into objects, and I'm going to position these objects at exactly those locations where these speakers would be. And that will essentially allow me to embed the 7.1.4 into a Dolby Atmos file. And that is exactly what we're going to do now. So let me click that away again. So the first thing I need to do is and now is the time, I need to prepare the Dolby Atmos setup. So I'm going to go into the Dolby Atmos bus, and I'm going to add the Dolby Atmos panner, or the Dolby Atmos renderer. So let's search for Dolby, renderer for Dolby Atmos. Here we are. And then I'm going to tell Cubase that I want to use a Dolby Atmos project. So I go in the ADM authoring for Dolby Atmos panel, and I'm going to choose the renderer. Once again, in Cubase, you only have the internal renderer. If you are in Nuendo, there are different options here. But for us here, this is perfectly fine. I'm going to add a bed. The bed that I'm going to add is the Atmos bed. Now, what I want to do is I want to use the first 8 channels, so essentially the mid information, the 7.1 of the 7.1.4, and I'm going to route those into the Atmos bed, and the 0.4 of the 7.1.4 I'm going to route into 4 objects. So what I need to do now is I need to take the 7.1.4 that I got out of the Ambisonics, and I need to somehow drop the overhead channels so that only the first 8 channels are routed into the Dolby Atmos renderer. Now, in order to do that, what I'm going to add is I'm going to add a helper track, and that helper track, the only purpose of that helper track is really to drop the overhead channels. That's the only purpose of that track. And the track that I'm going to use for that purpose is going to be a 7.1.4 track, because essentially all the 12 channels are going to come in, but only 8 channels are going to leave. So let me just add this group track, and the group track is going to once again be a 7.1.4. And it's let's route that into the bed, because essentially it's going to be a helper track that's going to help prepare the bed, right? So let's call that bed helper. Bed helper with an E, not with an A. So let's add that here, and let's move that up here, just above the head, and yeah, let's leave it gray. It's just helping. It doesn't really have any particular purpose other than helping. So, and what I'm going to do is I'm going to route the original test audio into that helper track, and the helper track is then routed into the Dolby Atmos bed, and the Dolby Atmos bed is routed into the Dolby Atmos renderer, which I already see here by this rectangle here. That essentially the first 10 tracks in the Dolby Atmos renderer are the bed of the Dolby Atmos project. So that means that I need to route the test audio into the Atmos, sorry, not from the Atmos bus into the bed helper. And if I'm doing that now, essentially what's currently happening is that the 12 channels are converted into 10 channels and then routed into the Dolby Atmos renderer, right? So if I'm playing now, I should actually have action on all 10 channels here. And what I want to do is I want to really drop the last 2, because the last 2 I don't really need. I only want the first 8, the 7.1. If I would be in Reaper, and this is actually one of the reasons why Reaper is so cool, I could do all kinds of things with routing individual channels. In Cubase, it's not that obvious, but we can essentially do similar things. At least we can do the things that we need to do in this particular case. So what I want to do is I want to drop the last 2 channels in the bed helper track, so that only the first 8 channels, I want to actually drop the last 4 channels, so that only the first 8 channels are going to reach the actual bed. And the way we can do that is by using the routing editor. And the routing editor allows me to essentially tell Cubase how the individual tracks are routed through a plugin. Now, I currently don't really have a plugin here, so I can't really route anything. So the first thing I need to do is I need to add a plugin. And it doesn't really matter actually what plugin you're going to use. We just use it as a dummy so that we can select the individual tracks that are routed and those that are not routed. But since I already add a certain plugin, why not use one that actually makes sense? The one that, there are a couple of different options, but what you can do, for example, is you can use an EQ, and the EQ that you can use is the multi-EQ from IEM. Now, the reason I'm using that multi-EQ from IEM is because it essentially operates on 16 channels. So I could actually use that as an EQ later on if I want to change certain the kind of the flavor of the audio. I can do that and can use that EQ. Now, we're not going to use it for us here in this particular video. I'm just going to use it as a dummy plugin that I'm going to use, so that I now have the routing editor available. And so what I'm going to do is I'm going to click on that routing editor, and I'm going to select, we only want the middle layer, the 7.1, and that will essentially make sure that only the middle, the first 8 channels are actually routed through the plugin. Now, I don't really the thing, there's one additional step that I need to take. I not only want these 8 channels routed through the plugin, I actually want to have the other 4 channels not routed at all. So what I'm going to do is I'm going to go into the routing editor. So I'm going to open up the routing editor. That gives me this routing editor window here. And I'm simply going to disconnect the last 4. And as soon as I've disconnected the last 4, Cubase is not going to route anything on the last 4 channels through to the next track. And all I have now is these 8 channels. And I also have an EQ on that if I want to use that, but if not, that's fine. And what I'm going to see now is, if I play that again, that only the first 8 channels actually have information on there, and there's nothing on the overhead channels. And that essentially means we now have the middle layer, so the 7.1 taken care of, and we now need to do essentially the same thing for the other 4 channels that we have. So for the 2 overhead front and the 2 overhead back channels, and we're going to use objects for that purpose. Now, the way this is done is pretty much exactly the same way. So I'm going to use a helper track that will take the individual tracks from the 7.1.4 and turn it into something that I can route into the Dolby Atmos renderer. Now, the maximum channel count for an object for the Dolby Atmos render is stereo, so I actually have to create 2 helper tracks, one for the front overhead channels and one for the back overhead channels, and then essentially I can use the routing, the Cubase internal routing into the Dolby Atmos renderer in order to route the 2 individual objects. Unfortunately, I can't do that in one piece, so I can't simply take 4 channels and route that into the Dolby Atmos renderer. That doesn't work. The renderer only allows stereo tracks to be routed into as objects, and that essentially means I need to create 2 helper tracks for the 4 channels that I have. So let's do that. So the first thing I'm going to do is I'm going to add another. So you see, it's going to be, as I promised at the very beginning, it's going to be fun, and we're going to have a lot of tracks that we're going to do. So let's add another group track, and the group track that we're going to add is this time is a stereo track, because we want to. Oops, sorry. So it's actually, once again, it is a 7.1.4. We are not yet at the objects. There are a couple of additional tracks we need to do. So it's a 7.1.4, and we're going to use this helper track in order to convert the 7.1.4 into the stereo, or kind of to extract the overhead information of the 2 overhead channels that we're going to select here. Let's route that into the bus. It doesn't really make any difference because we're going to route it into the renderer anyway. And let's call that overhead front helper. So that essentially means that we are using the 2 front overhead channels. These are channels number 9 and 10. And this is essentially kind of, this track is just made for that purpose, to extract those two tracks, or those 2 channels. So let's do that. And let's do the back one at the same time. So we're also going to use a second one, and we're going to call that the overhead back, not neck, back helper. And we're going to add that as well. And let's just rearrange them slightly. So I'm going to move them up here. Yeah, so let's leave the bed. Sorry, let's leave the bed track. So bed helper, bed, Atmos bed, and then we have the front helper, the back helper, and we're going to need 2 more tracks in order for the objects to actually work. So if I'm doing that now, currently, I will see some action here, but I'm not going to see that in the Dolby Atmos renderer. I did route these tracks into the Atmos bed track, but because essentially I already activated the Dolby Atmos renderer, essentially I'm not going to hear anything. And more importantly, currently I don't really have any audio routed into those tracks. So if I'm playing everything, actually I don't see any, or don't hear anything. So the first thing I need to do is I need to take the test audio, and I need to route those into the 2 additional helper tracks. So I already have that routed into the bed helper. I also want to route it into the front and into the overhead back. So let's open that up. Now, the way to do that, I can actually route to multiple. I can route to multiple tracks in Cubase, and the easiest way to do that is simply open up or kind of enable the direct routing window, and that will essentially open up all the direct routings that we have. And we want to add the overhead front helper and the overhead back helper. And we want to enable all three of them. So what I need to do is I need to press the Shift key and select them, and that will essentially select all three. So now the audio is routed into all three. And once again, because the audio essentially is then passed to the Atmos bus, and here we already have the Atmos. The Dolby Atmos render enabled. I'm not really going to hear anything, but I should already see some action here on the front and the back helper channels. So essentially I see all the action and I have all 14 channels. So the first thing I need to do is I need to extract the two channels, the front overhead and the back overhead. So let's go into the front overhead helper channel or track, and let's extract the two front overhead channels. We're going to use the very same trick that we used for the bad channel. So we're going to add an insert. We're going to add the IEM multi-EQ. And once again, it doesn't really make any difference which one I use. It just needs to be something that doesn't really affect the audio in any way, shape, or form. And then we're going into the routing. And now, instead of choosing the middle layer, we're going to choose the stereo, the top front left, top front right. Right? And that will only select these two. And once again, you need to go into the routing editor and deselect or disconnect the other 10. That should essentially do that. And let's do the same thing for the other helper, the back helper. Once again, let's add the IEM multi-EQ, and we're not going to need that. Let's go into the routing, and now we are going to select the right, the rear, so the back, the two back channels, the overhead back, and these are essentially 11 and 12, or yeah, 11 and 12, and then we're going to go into the routing editor, and we're going to once again disconnect those, and that should essentially make sure that only these two channels are left through. So let's see what happens now. What you should see now is that in these meters here for the top, for the front helper and the back helper, only two channels are actually active, and it's a little bit small to see here, but it should be able. So essentially you see that only the two that we selected are really active. So there's one final thing that we need to do, is because we actually need this information into the first, or we need to move them into the first two channels, because they need to be routed as a stereo track into the Dolby Atmos renderer. So what we can do is we go back into the routing editor. So let's go back into the routing editor, and here we have this link button. So what I want to do is I want to actually kind of take these two channels and I want to move them over here. So the way I can do that is by simply deselecting the link that kind of disconnects the link between the in and the out channels, and let's just move them over here. So we now have these two incoming and they're going out at left and right. And let's do the same thing for the other one. Let's close that again. So that's the back one. And open routing editor, deselect the link, and let's move them to the front. And now the two channels that are active in the front helper and back helper tracks should be the first two channels. So we are almost done at that point. The only thing left now is to take these two stereo tracks, they're technically stereo tracks, and to route them into the Dolby Atmos renderer. And in order to be able to do that, we need to actually have an actual stereo track. So the Dolby Atmos renderer will not recognize these tracks as something that can be routed into the Dolby Atmos renderer. So we first need to add additional object tracks that will actually be stereo tracks. So we are going to add 2 object tracks. So we're going to add, these are stereo. So they're going to go to the Atmos bus, doesn't make any difference. And let's call them the overhead front. And then let's move that up here to the, after the helper, and let's change the color. Let's make it orange. Everything that goes into the Atmos renderer is orange. And then let's add one more. And once again, it's a stereo. And that is the overhead back. And let's add that track. And then move it up again after the helper. And let's make it orange. The final thing is I need to route the helper tracks into the individual object tracks. So let's route the overhead, the front helper into the front overhead front bus, and the back channels into the overhead back channels. If I play that now, I should still see the information here. So I essentially have that as a stereo now. Now the because of the way essentially the panning is currently set, so these meters essentially are post panner. I see them as the first two channels in the track, because it believes that essentially it will be converted into a 7.1.4 file, but we're going to actually kind of take them before they are converted and route them into the Dolby Atmos renderer. Now I'm going to, just to make sure that nothing happens, nothing bad happens, I'm going to deactivate certain panners because I don't really need them. So for example, the 2 channels that are routed from the helper, front helper into the front helper into the front object track doesn't really do anything. So let's deselect that and let's bypass that. And then we can also do the same thing for the bad helper. We also don't have anything going on here. So let's bypass that. You don't need to do that. I just want to make sure that nothing bad can happen. So whenever I don't really need the panner, I just disconnect it and bypass it. And that is almost it. So the very last thing is I now need to route them into the objects of the Dolby Atmos renderer. So I need to create 2 objects. So let's add 2 objects in the ADM authoring for Dolby Atmos panel, and let's select the front and the back. And as I'm doing that, I see these 4 channels added to the objects in the Dolby Atmos renderer. And that's pretty much everything that we need to do in the ADM authoring for Dolby Atmos. And if I play that now, essentially I should see the first 8 channels in the bed and these 4 channels active. Now, at the moment, it's not yet particularly interesting because I have not yet panned the individual overhead channels. So I need to put them into the position where I would normally find the overhead speakers, so the front speakers and the back speakers. And this is a little bit kind of that this is not an exact science. You know, kind of this is not something that is absolutely exact. There's a certain variability in where exactly the speakers can be. So what you essentially need to do is, depending on the source file that you have, I would suggest that you simply try out what sounds best, what works best for that particular material. But in essence, the thing that you need to do is, let's just open up the panner for the front. So these are the 2 front overhead front channels. So what we need to do is we need to move them up. So the C direction, we need to move them up, and we see that here in the Dolby Atmos renderer. So essentially, I need to move them up and bring them in a little, and then move them back a bit. So here, so maybe here. That's fine. And once again, you can play around with those wherever you find them more appropriate for your particular material. It also depends a little bit on the type of effect that you want to create. If you want to heighten the effect, the height effect, or if you want to kind of have something that's a little bit more flat sounding, where you don't have this much 3D experience or 3D information, you would kind of position them accordingly. And let's do the same thing for the overhead back channel. So once again, we move them up. and we move them, we bring them in a little, and let's move them back, and let's move them here somewhere. So that sounds about right. And this is essentially it. So let's see how that sounds. And that sounds already all right, but I would also like to see actually how the energy is now distributed. So once again, let's go back to our energy visualizers. So let's go, first of all, let's take the one from the input. So that is the one energy visualizer that visualizes the original Ambisonics file. And then let's go to the energy monitor here. And that is the output. So once again, this is now the input, this is the output, and this is the output after converting it in the way we did that. So by turning into a 7.1.4, taking the first 8 channels, routing them into the bed, and taking the last 4 channels, routing them into individual objects. And let's see how that looks. And as you can see, I now have a much smoother distribution on top. So once again, the bottom is not something that I can actually experience, because once again, in Dolby Atmos there are no channels underneath. But all the other things are actually working correctly, and I'm supposed to be, or I'm expected to get a relatively good 3-dimensional experience. So once again, this is not an exact science on how you position these overhead speakers, so you can kind of change them a little bit in order to kind of make sure that everything sounds or works correctly. If you are working with Nuendo, you can also use a higher channel count. So what you could do, for example, is you could convert the Ambisonics into a high channel count A format. Really, that's what it is. So there are a couple of plugins that convert Ambisonics, for example, into something that is a 20 channel file, so where you have 20 speakers, and then what you could technically do, you could use the exact same approach in order to position these 20 individual speakers in 3-dimensional space, and thereby recreating an exact experience of the original Ambisonics in Dolby Atmos. That's something that you can do in Nuendo. You can't do that in Cubase. But for most purposes, the conversion that we are doing here should be more than enough. Once again, for the things that we are working with, if you're having any field recording, it's very unlikely that you have a lot of information coming from the ground. So the most of the information that's important to you will probably come from overhead, and that essentially means that the setup that we have here should be perfectly fine. Now, this is everything I wanted to say today. If you enjoyed that video, please don't forget to press the like button, because that is important in YouTube. This might have been a rather long video, and I hope I didn't lose you somewhere in the middle. If you got lost, just go back and rewatch it, or watch one of the videos that I did previously where I talked about Dolby Atmos and how to set it up in Cubase. If you have any questions, please use the comment section or join my Discord community and join the discussion. We had a very lively discussion after last week's video, and we even had some exchanges with the developer from the Mach 1 transcoder who gave some very interesting insights on why it works the way it works. So if you're interested in the topic, you will find like-minded people there, and there's a lot of additional information that you can get there. And did I mention it's also free to join? So I'm not really kind of monetizing that in any way, shape, or form. But with that being said, I think that's everything I wanted to say today. See you at the next video.